Hi guys! Welcome to the channel. Today I will talk about the difference between thermal conductivity and thermal diffusivity. While the two terms sound very similar to each other, their significances are different. Let's just dive into it. Thermal diffusivity is represented by alpha and it's the ratio of thermal conductivity, K, by the product of density and heat capacity. Now, what does this ratio tell us? Well, the numerator of the ratio tells us how fast heat is getting propagated through the system, and the denominator tells us how much of this heat is getting absorbed by the system to increase its temperature by 1 degree Celsius. Or the amount of heat required to increase the temperature of a unit volume of the material by 1 degree Celsius. What does that mean? That means that how much of the heat is going to get transferred through my system is given by K. But how much heat is required in trying to increase the temperature is given by the denominator. Let's understand it through an example of two bodies which are red and green. Let's just assume that the thermal conductivities of both bodies are equivalent and the thermal diffusivity of the red body is lower than that of the green body, which means the heat capacity of the first one is higher than the heat capacity of the second because the thermal conductivities are equal. Intuitively, it means that even though heat is getting transferred at the same rate in both bodies, the red body will require a lot of heat to get a temperature rise by 1 degree compared to the green body. And why do we care about the temperature rise is because there are certain applications sensitive to temperature rise, for example in the electronics industry. Let's just now look at the other example, of black and blue body. The black body has a greater thermal diffusivity than the blue body, which means the rate of heat transfer will be high in the black body, which has a greater alpha. But if you want to look into the temperature rise, then have to look into the heat capacities of the system. To summarize, the larger the value of alpha, the faster heat will diffuse through the material. Thermal diffusivities are significant in unsteady state heat transfer because the steady state final temperatures are not reached yet. Also, thermal conductivity has the units of a watt per meter per degree Celsius and thermal diffusivity has units of meter square per second. That's all for this video. If you found this helpful, please like and subscribe for encouragement. Bye.